In this problem, Snook has an n-sided fair dice and he has some number k. And what he wants to do is he wants his score to reach k or above to win, and if his score is 0, he loses. So after he rolls his dice and gets some number, that's his current score. And then what he can do is he flips a fair coin, and if it's head, his score becomes twice as large, and if it's tail, his score becomes 0 and he loses. So we want to find out the probability that Snook wins the game. It sounds complex, but let's look at the very first example, right? So it's a three-sided dice, so he can either get a 1, 2, or 3. Now, since it's a fair-sided dice, there's an equal chance he'll get each of those numbers. So it's 1/3 for a 1, 1/3 for a 2, 1/3 for a 3. And let's keep that for a side. Now, let's say he gets a 1. How many turns will it take him to get a 10? So if he gets a 0, he'll just lose. So the only way to get a 10 is he needs to hit heads on every single coin flip until he reaches or becomes higher than 10. So 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16. So he needs 4 heads in a row to win. And that's if he gets 1 on his dice. Then if he rolls a 2, then 2 becomes 4, 4 becomes 8, 8 becomes 16. He now only needs 3 heads on his coins to win. And then if he gets a 3, 3 becomes 6, 6 becomes 12. And then he only needs 2 heads on his coin flips to make his score of 3 to become something larger than or equal to 10. Right? So overall, if you just look at the very basic math here, so there's a third chance to get 1, and so half times 4 is the probability that he'll land a heads 4 times in a row. Right? So it really is the probability of getting higher than or equal to 10 starting with 1, starting with a dice roll of 2, and starting with a dice roll of 3, all summed up, which is equivalent to this. Right? So the first thing to notice is there is 1/3 common in all of these. So we can do that at the very end. So we just need to find out the number of times we need to get heads in a row to make this number larger than or equal to the number k. And once we do all of that, we sum them all together, and then we times all of that by 1/3, because we can take 1/3 out in common in all of this. Okay, so let's try and code this, right? So we're given n and k. So let's make it double n k, and let's also have something called answer, right? And then we'll read in n and k. So I will be the number we assumed we get from the roll. Alright, so it can be anything from 1 to n. Alright, so we need to count the number of rolls it takes to be larger than or equal to k, the number of coin flips, right? So let's call flips and make this 0. And then in temp equals I. So let's not mess with I, let's just create a temp variable and then change that. So while temp is less than k, right? Because then we know it's too little. Then we can change temp to be twice as large, and we assume we get heads, and then we know we increase the flips by 1. And then after we do that, ans becomes 0.5 to the power of flips. That makes sense. And then we would just see out set so let's set the answer precision to 10 dp, and then we output answer. Okay, let's see if this is right. Nope. Oh yeah, because what we have done so far is we've summed all these values. Now we need to times this entire sum by 1 over n. So we just have to divide our answer by n. Would this work? 0.14583. Okay, so now let's just go over what I did one last time. So here we go over all the possible dice rolls we can get, so which are the numbers 1 to n, and that is I. And here in flips, we'll keep count of the number of flips we need to get heads such that our score is larger than or equivalent to k, right? So over here, we just keep on flipping temp until temp is bigger than or equivalent to k, right? And then we count the number of flips. Now that we count the number of flips, we do what they do here. So it's a half chance that we get a head on each flip, right? So for Snook to win the game, we need to get heads flips times. So it's just the half to the power of flips, and we add them all up together, and then finally we have to multiply everything by 1 over n, and that's why we divide our answer by n over here, and that's how we get our final answer. So let's see if this works here. 0.999737500. Yep, that looks good to me. And voila.